Travis Gillespie, and I want to talk to you about some very special functions. And these are functions where the actual domain is only represented by natural numbers. So numbers such as 1, 2, 3, 4, 5, 6, 7, and so forth. In that case, you can actually list the function by just listing the y values, that being the y values associated with 1, 2, 3, 4, and so forth. In fact, these types of lists are called sequences. Sequences are very special examples of functions where the input, the domain, is actually a set of natural numbers. A sequence is a list that often forms a pattern. Each number in a sequence is a term. So 1 would be a term, 2 would be a term, 3 would be a term. Now there are lots and lots, many types of sequences, but a really famous type of sequence is known as an arithmetic sequence. That's the one that I'm going to spend some time working with you on today, arithmetic. You know that M's really sloppy, so I'm going to go back and fix it real quick. Cool. And these are sequences where you can look at a list of numbers and see a pattern. And to get from one number to the next number, such as to get from 1 to 2, oh, you just add a particular amount. So to get one from one number to the next, you add a particular amount. And to get to the next number, so say from 2 to 3, you just add the same amount as you did before. So really, you see that in consecutive terms, such as 1, 2, 3, 4, so forth, in an arithmetic sequence, you will have a common difference. And what you do is you subtract one from the other. You always see the same number. That would actually indicate, yes, this common difference is telling me it's an arithmetic sequence. Well, let's take a look at some examples here and determine if each sequence appears to be an arithmetic sequence. And if so, let's find that common difference, and then let's actually find a few more terms. And just know that the common difference will have to be a non-zero value. So here's our first function or sequence that we're going to think of them as a list here. So let's say that I have the values 30, 25, 20, and 15. Cool. And then again, so forth. So let's see if we have a common difference here. So I'm going to grab a new color and say, okay, well, if this actually, let's take the difference of 25 and 30 here. So 25 and 30, you guys can probably do it in your head pretty quick. 25 minus 30 would actually equal -5. And then take 20 and subtract 25. So 20 minus 25 also gives you -5. Okay, and now you see that, yes, 15 minus 20 actually gives you a value of -5, so there is a common difference here. Cool. So the common difference is -5, and if this were to continue, you would say yes. If this were to continue, then you would actually have an arithmetic sequence. Because, well, that's what's required of a sequence. it has to conform to this common difference, in this case, -5. So if you do have an arithmetic sequence, what would be the next few terms here in the list? And you can actually predict them just as seen before. So go back to my blue pen here, and I'm just going to rewrite the sequence here. I've got 30, oops, so I have 30, well, 25, then 20, and 15. Cool. So uh, what would you do? Well, the first thing, you see the pattern. Well, subtract 5. Okay. The next three terms I would predict would be, okay, well, subtract 5 from 15 would be, let's change colors here again. Those last three terms would be 10, because 15 minus 5 is 10. 10 minus 5 is 5, so and then 5 minus 5 is 0. So, in fact, this sequence really is an arithmetic sequence here, because there is a common difference of 5, and that is a -5, not a +5. There's a common difference of -5 between terms. Cool, so let's border this up here. All right, and I'm done with that problem. And let's go look at another problem here. The next problem that I'm going to go to, let's just write a list of, oh, I don't know, 1, 4, 9, and let's say, oh, 16. Okay, so the first thing we want to do is find a pattern. Let's find the difference here. Well, the difference of 4 and 1, so 4 minus 1 is 3. And then my next difference here, well, my next difference is 9 minus 4. Well, that is actually 5. And then my last difference, I already know it's not going to be an arithmetic sequence, but 16 minus 9, we've got 7. Well, yeah, sure, there is a pattern. These are the difference of my differences between terms are actually 2, but however, there is no common difference because the difference between terms is increasing in increments of 2 still. Therefore, there is no common difference. Therefore, there is no arithmetic sequence. Not an arithmetic sequence. Well, cool. Let's move on to another problem.